Genius Kids. Cultivating love for learning.
Chapter 15. Electric Current. Knowledge Acquisition. Conductors insulators are already discussed by us in the previous classes, so in this class we will lay emphasis on conducting power of different conductors or current produced by different conductors, chemical effects of electric current, electrolysis and an application of electrolysis. Discussion. Jack. It's really great and feels good when every time in every next class we move one step ahead. Susie. Yes, Jack, it feels good. Come on, let's understand more about electric current. Conducting power of different conductors. Conductors are those materials that allow electric current to pass through them. Although aluminium, brass, iron, kerosene, lemon juice, salty water, etc. are all conductors, but have you ever wondered about their conducting power? Do all of them allow the bulb to glow with same intensity? The answer is no. Critical thinking. Electricity travels at the speed of light more than 186,000 miles per second. Intensity of light produced by an electric device is judged by heating effect of current flowing through it. More the current, more is the heat, more is the light produced. Indirectly or directly, we can say that current of 10A will produce more light in a LED as compared to the current of 2A LED, light emitting diode. Conducting power of different conductors allow their classification into poor and good conductors of electricity. Poor conductors are those that allow the passage of little current through them, whereas good conductors allow more amount of current to pass through them. For example, tap water and kerosene are poor conductors, whereas salt solution and lemon juice are good conductors. One very important point that can be drawn out from above examples is that salt allows conduction of electricity. That is why salty water is a good conductor as compared to tap water, which contains less salt. So we can conclude that pure water or water without any salt content must be an insulator. Critical thinking. Thomas Edison is created to have invented the first light bulb. But you know what? He did not invent the first light bulb. But he did invent one which stayed lit for a few seconds. Electrolysis. The process of breaking up of an electrolyte chemically on passing an electric current through it is called electrolysis. A substance which conducts electricity in the liquid state or when dissolved in water and breaks up chemically during the process is called an electrolyte. Let us demonstrate the process through an experiment. Experiment to demonstrate chemical effect of electric current on water. Take 2 iron nails. Clean them with sandpaper. Wrap 1 or 2 rounds of copper wire around them and connect the other ends of the wires to the 2 terminals of battery. Take water in a beaker and add to it a little salt or a few drops of sulfuric acid to make it conducting. Immerse the nails, called electrodes, in the solution. Observe the nails carefully. Can you see small bubble of gases coming out from the water near the nails? It can be checked that the gases evolved are hydrogen and oxygen. When an electrolyte such as copper sulfate is dissolved in water, it breaks up into positively and negatively charged particles called ions. Positively charged ions are called cations, while negatively charged particles are called anions. When electric current is passed through the solution, the cations move towards the negatively charged electrode, cathode, and anions towards the positively charged electrode, anode. Electrolysis finds its use in various chemical applications such as refining and extraction of metals, electroplating, etc. Dry cell. A dry cell converts chemical energy to electrical energy. Each dry cell can produce a voltage of 1.5 V. Chemical energy can be converted to electricity. But the reverse is also true. Passage of electric current can also allow or can assist in chemical reaction to occur. Critical thinking. A generator is a device that converts mechanical energy to electrical energy. The process is based on the relationship between magnetism and electricity. Internal structure of a dry cell. Dry cell consists of two electrodes. Electrode is metallic strip or a wire that allow the current to pass through. The electrode connected to negative terminal of the battery is cathode, and that connected to the positive terminal is anode. So cathode being negative attracts cations, positive ions, and anode being positive attracts anions, negative ions. In the center of the dry cell there lies a carbon rod that remains surrounded by electrolyte. Generally, ammonium chloride and zinc chloride paste is used in dry cell. Electroplating. Electroplating is the process of plating one metal onto another by hydrolysis, most commonly for decorative purposes or to prevent corrosion of a metal. There are also specific types of electroplating such as copper plating, silver plating, and chromium plating. The purposes of electroplating: 1. Appearance. 2. Protection. 3. Special surface properties. 4. Engineering or mechanical properties. Applications of electroplating. Electroplating allows manufacturers to use inexpensive metals such as steel or zinc for the majority of the product, and then apply different metals on the outside to account for appearance, protection, and other properties desired for the product. The surface can be a metal or even plastic. Continuous review. Different conductors have different power to generate current. Chemical energy can be converted to electric energy. Electrolysis is a very important commercial phenomenon.
Like, share and subscribe.